Tonight's video, we're going to look at the formation of the solar system and the formation of the universe. All right, this is our last set of notes for the astronomy unit. Getting ready for our final astronomy test next week, which is going to cover types of stars, star clusters, galaxies, and the formation of the universe. So let's get started. So in this, we're looking at the scientific explanation for the formation of the universe, right? So we're always looking for what do we have scientific evidence for? And looking at the universe today, our evidence shows that about 13.7 billion years ago, all of the matter that is in the universe today was compressed to something the size of the period at the end of this sentence on screen, which is really hard to picture. All of the stars, all of the everything compressed to something so infinitely dense that it fit into the size of this period. And for whatever reason, we still don't really know why, that material exploded outwards, and we call that the Big Bang. All right, so this is about 13.7 billion years ago. We had all the matter in the universe compressed to a single point. I'll help you guys out a little bit at the start of the notes today. 13.7 billion years ago, all matter in the universe compressed to a single point. And then for some reason, that matter exploded outwards. And is still expanding. A, how do we know that this happened? And B, how can we put a time on it, right? 13.7, right? That's fairly precise. It turns out we do have some good amounts of evidence for this. First point of evidence for the Big Bang is we can measure how different galaxies are moving relative to each other. Right? And it turns out that all the galaxies in the universe are expanding. All right? So you guys are going to take your own notes for this section. All the galaxies are moving away from each other. If we were to calculate backwards based on where they are now, and if we were to go back and calculate where they were, it turns out they all come from a single point, and they would have started about 13.7 billion years ago. So that's one way, one piece of evidence for it, is by looking at how the galaxies today are moving. The other evidence is what we call background radiation in the sky. And so when the Big Bang happened, right, this was an enormous amount of energy, and it created an enormous amount of heat. And so when this went off, it would have released a lot of light and energy into the sky. Now, we've talked in class about how light takes a certain amount of time to travel a certain distance, right? And that's how we get a light year. So, if we were to look 13.7 billion light years away, light from there will have taken 13.7 billion years to reach us. So any light from that far away should be light from the beginning of the universe. And it turns out, if we look 13.7 billion light years away, that is exactly what we find. Right? It's very weak because it's coming from so far away, but it's from all over the sky. We have this weak background radiation from all over the sky coming from 13.7 billion light years away, which indicates that there was some explosion that happened then. So then how did we get our solar system, right? So we have all this matter expanding through space, right? After the Big Bang, this matter starts to slowly pull itself together into galaxies, all right? And within galaxies, nebulas begin to form. Right? So in the Milky Way galaxy, the nebula that eventually became our sun started to form. Gravity pulls our nebula closer and closer together. Eventually, the gas in the middle becomes so dense that nuclear fusion begins. Right? Just like the formation of any other star. We have a proto-sun, and now we have our sun in the main sequence. Now the planets, right, are formed from kind of what was left over. So there was some leftover remaining material that was from the nebula that was orbiting our new sun. And so gravity starts to pull that stuff together over time, and that material clumps together to create the planets, the asteroids, comets, and all that other stuff. This happened, as best we can tell, about 4.6 billion years ago. Right? So again, the Big Bang, 13.7 billion years. Our solar system, about 4.6 billion years. And you should know those numbers. So what happens next? Right? Basically, astronomers have figured out that there are two options. So the future of the universe. Right? Now, our sun will eventually turn into a red giant, burn out, and collapse in and become a white dwarf. But the universe itself, there's kind of two options. First, gravity eventually takes over, right? So as we can see, over time the universe is expanding. This is where we are right now. One theory says that the universe will stop expanding and then gravity will take over and pull things back together into what's called the Big Crunch. The other option is that inertia of all these galaxies moving apart is too strong and everything keeps moving apart forever. And based on the observations that we've made of galaxies and things in the sky, it seems like this second option, right, expansion, seems to be more likely, that the universe will keep expanding forever as best we can tell. So, write down 3 questions. I'm sure you have some. And we will talk about this stuff in class on Monday.